There's a mysterious zone far out in our solar system. It's a region of ice worlds, some solitary, some with moons. Their names may be unfamiliar: Eris, Makemake, Haumea, but they hold clues to all our origins. And the first of these worlds, and the one we'll reach in 2015, is the king of the Kuiper Belt, Pluto. The long journey of NASA's New Horizons mission began in 2006 aboard America's biggest, baddest rocket, tricked out with every conceivable booster.
We built a very light spacecraft and bought a very large launch vehicle, and the combination is ferocious.
But in some sense, it all began in 1930 with Clyde Tombaugh, 24 years old and fresh off a farm in Kansas, but willing to spend long hours scanning star fields to find a moving point of light, humanity's first glimpse of Pluto. The dream of actually getting to Pluto began with a 6-year-old boy in love with science, who grew up to lead a team of brilliant researchers and engineers with dogged persistence through decades of planning and building and testing. A race against time just to get to the launch pad.
Exploring the outer solar system, because it's so far, takes a lot of time. It requires a lot of patience, a lot of dedication, a lot of perseverance, but it's the frontier.
Assuming all goes well at Pluto, NASA may choose to extend the adventure further out into the Kuiper Belt, the solar system's mysterious third zone.
This is maybe the one chance in my lifetime that we're going to get a spacecraft out there and look up close at one of these Kuiper Belt objects.
December 6, 2014.
We have an nominal wake up of the New Horizons spacecraft.
New Horizons wakes up for the last time from hibernation.
New Horizons is speeding towards Pluto at a phenomenal rate, and we can't wait for it to get there.
January 27, 2015, 6 months of approach science begins. July 14, 2015, New Horizons' long journey, 3 billion miles, 9 years in flight, and 85 years of speculation about Pluto, climaxes in one day of close approach and flyby.
You know, we're rounding third base and we're headed home.
The dream, the adventure, the promise of discovery. That's what makes 2015 the year of Pluto. Studying Pluto and its neighbors from Earth is one of the toughest challenges in astronomy. It takes the largest telescopes and most advanced instrumentation on the planet. And it's tough even for the Hubble Space Telescope. And it takes time, from the discovery of Pluto in 1930 to NASA approving the New Horizons mission in 2001 to arriving at the planet in 2015. It's been 85 years, and time passing is definitely an actor in our story. But it's the combination of human skill, cutting-edge image processing, and sheer bloody-minded persistence that has resulted in the most important discoveries. And that's a tale as true today as back in 1930, when Pluto was first found by Clyde Tombaugh. In 2011, at the SETI Institute near San Francisco, Mark Showalter used Hubble data to discover 2 new moons around Pluto, although he was actually looking for possible rings. Showalter has found rings associated with small moons around other planets.
And that was kind of the motivation for checking out Pluto. It's got 2 little satellites. Satellites raise clouds of dust. Let's see what might be there.
It's easy to take artistic license to show what Pluto's rings might look like. In reality, it's incredibly hard to see faint objects against the dense background star field and the glare from Pluto and its large moon, Charon.
We came up with this trick where you take the images and then you rotate the camera 90 degrees, you take more images, and if you do that all just right, you can do this thing where all that glare cancels out, and what we're left with is just the rings. We could think of it as a stack of images. Think of it as like a cube looking down. So let's turn it on its side. So now if we start peeling off the layers and looking downward through the stack, things suddenly become much, much cleaner. For example, Hydra and Nix show up very, very cleanly. But the thing that immediately caught my eye was this little dot. right there. It's not a perfectly sharp hot pixel like over here, and that's what made it pretty convincing to me that we had seen a very small moon of Pluto that nobody had seen before.
To be sure you've detected a real moon or planet, you have to show it's moving, unlike the background stars.
The thing that makes moons distinctive is if we come back later, they'd all have shifted because they all orbit the central planet. This required a great deal of patience to then wait about 6 days until we got our next set of observations of the Pluto system. Sure enough, the object was still there. It had moved by just about the right amount to be something orbiting Pluto, and we knew we had a moon.
Next year, Showalter and colleagues went back and built on lessons learned to see what else might be there. Summer 2012. Now, Mark had 15 more days of Hubble observations.
Now, what you can see here are 3 time steps. Each of those time steps is actually about 45 minutes of data. That means it's long enough that the little moons move. It's moving back and forth in this 3-frame sequence. Hydra is moving, Nix is moving. I mean, it doesn't take a rocket scientist to say that that looks like a little moon of Pluto. It's moving just the way the others are. They're all going around the planet in the same direction. And so it was just a couple of weeks later that we made the announcement that the 5th moon had been discovered.
Patience, persistence, ingenuity. That was exactly what led to the discovery of Pluto back in 1930. In Kansas in the 1920s, Clyde Tombaugh grew up in hard times and built telescopes using leftover farm implements. To check the accuracy of his best telescope, he sent drawings of Mars and Jupiter to the Lowell Observatory in Flagstaff, Arizona. They were looking for staff, and he was hired. Along with observing the stars, he stoked the furnace and shoveled snow. But one assignment made history. Day after day, he'd use this machine, known as a blink comparator, to look for anything in his images that moved. It was tedious, painstaking work, but on plates taken on January 23rd and 29th and analyzed in February, he saw a small dot that did move against the fixed stars. Announcing the results after careful confirmation, the observatory made it easy to find the new planet by adding arrows.
This is an incredible work of observational astronomy, and having done something similar but with much more powerful tools, I can really appreciate his achievement.
For decades, Pluto remained, more or less, a point of light. But in the mid-70s, Dale Cruikshank and colleagues attached cameras with infrared filters to a telescope at Kitt Peak.
Detectors or sensors had been improved, and larger telescopes had become available. Well, we did that work in 1976 and found evidence for frozen methane on Pluto's surface. It was several years later that we found evidence for the other ices.
In 1978, astronomers Jim Christie and Bob Harrington analyzed new plates taken at the U.S. Naval Observatory in Flagstaff. Christie noted an elongation to the north of Pluto. 1 month later, the bump had disappeared. From this and other evidence, they concluded that Pluto, like Earth, had a moon, Charon. From eclipses between Pluto and Charon occurring in the 1980s, astronomers calculated that the moon was almost half the size of its parent body, so large that both objects spin around their mutual center of gravity, outside Pluto. Pluto and Charon were the first double dwarf planet combo discovered in our solar system. Using the basic physics of their orbits and the distance between them, astronomers could calculate their mass and size. Pluto was a little smaller than Earth's moon, about 1,500 miles in diameter, and had only 1/10 its mass. Between 1985 and 1990, astronomers were in luck. As Pluto and Charon orbited their mutual center of gravity, each passed in turn in front of the other. The so-called mutual events allowed astronomers like Mark Bowie to capture the changing patterns of light. Patiently, Bowie created a map of Pluto. Pluto turned out to have one of the 2 most contrasty surfaces in the entire solar system. In the mid-90s, Bowie and Alan Stern used the Hubble Space Telescope to make the first direct images of Pluto's surface.
And it's exciting to Mark and I and to our whole scientific team to be able to see this object that no humans really could glimpse as a real planet, as a real object in the solar system previously.
In 2005, Hal Weaver and Alan Stern used the Hubble for another close-up look at Pluto and Charon. They discovered two small, dim moons where only Charon had been seen before. Now we know from Mark Showalter's work that there are two more moons, making the current total of 5, and that Pluto is a genuine mini-planetary system. From its size and orbit, astronomers estimated that Pluto is perhaps 70% rock and 30% ice. That makes it one of the largest of a whole new class of objects, the ice dwarf planets, making up what's known as the Kuiper Belt. This region is named for Gerard Kuiper, a leading mid-20th century planetary astronomer. Kuiper suggested that the solar system didn't end with Neptune and Pluto, but that there should be a disk of other worlds beyond them. In 1992, from a mountaintop in Hawaii, David Jewett and Jane Liu found the first Kuiper Belt object. They were using new and highly sensitive CCDs, like the sensors in a modern digital camera. But their technique was essentially an updated version of Tombaugh's work. Take carefully registered images of a patch of sky and see if anything moves against the distant stars. This one, QB1, did just that. It was only a few hundred kilometers across, 10 times smaller than Pluto, but still huge compared to a comet. Since then, teams of astronomers have found around 2,000 KBOs. Informed by cutting-edge astronomy, but with a fair dose of artistic license, let's take a trip through this third zone of our solar system.
We used to think of the solar system consisting of two different types of planets. The planets we call the terrestrial planets, which are Earth-like planets. That would be Mercury, Venus, Earth, and Mars.
Next out, the asteroid belt. Fragments of worlds smashed to pieces by gravitation and collisions. Then come the 4 gas giants. Jupiter and its moons. Saturn with its magnificent rings. Uranus, also ringed. And Neptune.
And then Pluto was this kind of, odd guy out. It was this little object at the edge of the solar system. And then when we found all these other Kuiper Belt objects, this is kind of almost a third type of object.
So for the first time ever, we'll be able to fly by a brand new object, an object that's been forming for billions of years, and understand what outer parts of the solar system are all about.
By July 2015, we'll know for sure what Pluto and its moons look like, and that will provide breakthrough information on all those other ice dwarf planets, the most numerous planetary objects in the entire solar system that make up the Kuiper Belt. Actually, the Kuiper Belt is more like a donut, bulging up above and down below the ecliptic where most of the planets move.
It's kind of like the asteroid belt, but much bigger. It has hundreds of times more objects in it than the asteroid belt.
Let's now visit 5 named KBOs in the exact positions they'll be in on July 14th, 2015, the day when New Horizons flies by Pluto. Quaoa was one of the first Kuiper Belt objects discovered. It's about 1,000 kilometers in diameter, a reddish world, covered in water ice, methane, and ethane. And like many KBOs, it has a tiny moon of its own, Wayuut. Up above and down below the plane of the solar system, numerous KBOs have been flung about by Neptune's gravity. This region is known as the scattered disk. One of the largest of these KBOs, Eris, is close in size to Pluto and is made of rock and methane ice. Astronomers categorize KBOs by the tilt of their orbits relative to the plane of the solar system. And one of the more highly inclined orbits belongs to Makemake, named for a Hawaiian creation deity.
Some of these have methane or water ice on their surfaces. Some of them just seem to be covered in some brownish gunk. There are gray objects out there. There are brown objects out there. There seem to be distinct populations.
Some of them seem to be very spherical, and so they probably have warm interiors, and then others are peculiar shapes which suggest they're very cold and strong.
Perhaps the most bizarre and unexpected KBO is Haumea, a KBO shaped like an American football, made of rock and ice. It's white with red splotches, and orbited by at least 2 moons. One of the strangest orbits of any KBO belongs to Sedna, discovered in 2003. Its orbit is the most eccentric of any KBO now known, bringing it as close as 76 AU to the Sun, but then carrying it outward to 936 times the Earth-Sun distance. Sedna's strange 11,000-year orbit seems to link it to an even vaster cloud of objects, ready for exploration by future generations. The Oort cloud is an immense icebox of long-period comets, from 10 to 100 times more distant than the Kuiper Belt, surrounding all the known worlds of our solar system.
There's a real record of the early history of the solar system out there in cold storage at the edge of the solar system.
This is what was left over. Pluto is the first member of that group.
But to begin humanity's exploration of the Kuiper Belt, you first have to get to Pluto. And that means getting a mission approved, a spacecraft designed and built, and delivered to the launch pad on time. And none of that was easy. "2015 may be the year of Pluto, but getting there has taken many long years of effort. And for New Horizons, there's a date when things got started: 1989. It was the year when George Herbert Walker Bush became president and the Berlin Wall fell. Far from Earth, it was also the year when NASA's Voyager spacecraft flew by Neptune and returned the first images of its moon, Triton. Hairstyles of some New Horizons scientists were very different, but for them, May 5th, 1989 was a most important date.
That's the day that I marched into the then Division Director for Planetary Science at NASA headquarters, Jeff Briggs, as a graduate student, and asked him why we aren't studying a mission to Pluto. And he responded, "Because no one's ever asked me before. That seems like a brilliant idea. Why don't we do that?"
Space missions rely on hundreds, if not thousands of people, but sometimes it takes someone with passion and persistence to make things happen. And for New Horizons, that's Alan Stern.
I was interested in this when I was a boy, so I've been somewhere between in the groove and stuck in a rut for 40 years.
There'd been some thought about sending one of the twin Voyager spacecraft past Pluto to complete the exploration of the known solar system. But in the 70s, the scientific establishment wasn't convinced Pluto was all that interesting. Young grad students like Alan, Mark Bowie, and Fran Bagenal thought differently.
Back in, about late 1989 or so, there was a bunch of us who were really keen to go to Pluto.
And the thing that drew me to it the most was the fact that we knew so little. Here's the frontier.
So it was a bit of an opportunity for young people to come in and say, hey, where are we going to go next? What's the next great frontier that we should go explore? And it was clear, out to the Kuiper Belt.
Alan, Fran, Mark, and a small band of enthusiasts became known as the Pluto Underground.
So we realized to make this happen, we had to get together and campaign hard to make the case to go there and explore this little planet with all its moons.
All through the 90s, there were many competing plans for a Pluto mission, like the Pluto Fast Flyby, the Pluto Kuiper Express. A Pluto mission was on, then off, then on, then off.
If the Pluto mission had been a cat, it would have been dead long ago because they only get 9 lives. And we've had significantly more than 9 stoppages and odd twists and turns.
What finally turned the tide was the National Academy's Decadal Survey, a consensus document from leading planetary scientists that ranked a Kuiper Belt Pluto mission highest in priority for medium-class budgets. Finally, after competitive proposals were evaluated, New Horizons, which teamed Alan Stern with the Johns Hopkins Applied Physics Laboratory, APL, and several other institutions across the country, was selected by NASA on November 29, 2001. Now, plans on paper became metal in clean rooms. In 2004, lead scientist Alan Stern described the mission's key science objective.
Well, you know, the key to planetary science is that you really have to go places to get the resolution, to get up close enough to really see what's going on. We want to get up close and personal.
The very best resolution of current telescopes looking at Pluto would give this kind of fuzzy image of a much more familiar world. But here's what New Horizons would see if flying over New York City, lakes in Central Park, wharves on the Hudson River.
New Horizons is the first really of a whole new breed of spacecraft that is focusing on a very specific task.
For this first mission to Pluto, the questions are basic. What do Pluto and Charon look like? What are they made of? How do their atmospheres behave?
We had to really be disciplined and say, we can't do everything. Let's focus on the primary questions and design the instruments to answer those primary questions.
The long-range imager, LORRI, will be used for navigation approaching Pluto and close-up views during the flyby. The wide-angle camera, RALPH, has both visible light and infrared sensors to map Pluto and Charon and characterize their icy surfaces. There are 2 fields and particles detectors to probe the solar wind at Pluto. The large radio antenna is an essential communications device, but both REX and ALICE, an ultraviolet imaging spectrometer, are part of experiments to analyze Pluto's atmosphere. And there's the Venetia Burney Student Dust Counter, built by undergrads at UC Boulder, and honoring the schoolgirl who named Pluto back in 1930. Together, the 7 science instruments comprise the most powerful set of detectors ever sent on a first flyby of any world in our solar system. But their innovative and highly miniaturized design means that even when all are operating, they draw less power than half a 60-watt bulb, and they're intended to work together seamlessly. After building comes testing, but always with an eye on the clock and the calendar.
It's very, very important that we launch in either 2006 or 2007. We have to make that deadline.
If you want to fly to Pluto on the quickest route, you need Jupiter in position. And that means we have to launch in January of 2006.
It feels a little bit like being strapped to a train going 500 miles an hour.
The test program involves teams of engineers at Johns Hopkins APL and then at NASA's Goddard Space Flight Center.
Once we launch this, we can't go after it with a screwdriver. We can't go fix anything that isn't working.
We make sure that we carry plenty of spare equipment on board the spacecraft. If our main computer breaks, we have a backup. If our main transmitter breaks, we have a backup.
One of the things we do is we put the whole spacecraft on a gigantic vibration table, a paint shaker, and shake it. And then test it after that, and shake it again and test it again. So that's what we're doing from now until launch.
Along with testing the spacecraft, New Horizons needs to train and test its human operators. And for a mission planned to reach Pluto in 2015, it's important to have young people on board early, so they'll be around at close approach.
It's good that we can do that, so they will have both the time, the focus to stay with the mission over this long period of time.
Many of the faces you see around Mission Control in 2004 and 2005 are young and enthusiastic spacecraft engineers.
Normally we're focused on subsystems and instruments in the spacecraft surviving that duration, but for people we have to have a longevity plan.
They'd be committing the prime of their careers to this mission to Pluto, knowing they'd be a decade older when New Horizons reaches its primary target.
The ability to practice things in those years far out there are all part of the planning now to assure mission success then.
How old are you going to be?
In 2015? I don't know, somewhere in my 40s.
Oh, and you're a youngster.
Yes.
In late 2005, the action shifts to Cape Canaveral. New Horizons may be light and relatively small, but launching it to Pluto requires America's most powerful rocket, the Atlas V. New Horizons will be traveling so far from the sun that solar panels wouldn't be sufficient. So the Department of Energy delivered an RTG that would power the Pluto mission by turning heat from the radioactive decay of plutonium into electricity. Working round the clock, they arrive at Pad 41 before dawn. On behalf of NASA and the entire New Horizons team, Stern wanted to be the last to bid the spacecraft bon voyage before closing up the hatch. On January 19, 2006, after 17 years of planning, building, and testing, a picture-perfect launch that thrilled onlookers in Florida and the mission operations team back at Johns Hopkins in Maryland.
We have ignition and liftoff of NASA's New Horizons spacecraft on a decade-long voyage to visit the planet Pluto and then beyond.
Despite immense technical and timetable challenges, the mission had made its window and was on its way. New Horizons' velocity at launch was the fastest ever, traveling almost 60 times faster than a jetliner. In just 9 hours, it passed the orbit of the Moon. Apollo had taken almost 10 times that long. 1 year later, a slingshot gravity assist from the giant planet Jupiter provided another 2 kilometers per second boost, cutting travel time to Pluto by 3 full years. But this was more than just a jump in speed. The Jupiter flyby was a scientific dress rehearsal for Pluto. New Horizons instruments returned detailed images of Jupiter's clouds, moons, and rings.
We got the night shine. Oh, wow, look at that.
Then it was off across the empty ocean of space, with no new land in sight till Pluto in 2015. The spacecraft had been tested and passed with flying colors. Now it was time to test the humans and the ground systems. July 5th, 2013, it's day 1 of a 9-day encounter rehearsal.
The main success criteria for this rehearsal is for the spacecraft to flawlessly perform its activities as if it were at Pluto, with everything the same, except that Pluto's not there.
The dates in 2013 were carefully chosen so that Earth received times would be identical to those for the real encounter in 2015. Mission managers wanted scientists and engineers to experience the stress of time-critical 24/7 operations expected for July 2015.
We're flying by an object that is a huge distance from Earth, and we're trying to hit a box that's 100 by 150 kilometers wide. And that then leads into maneuver planning and trajectory control needed to thread that needle and hit that small box. It's way the heck out there.
This rehearsal would actually be uploading commands to New Horizons to instruct the spacecraft to run through the exact same set of observations as in 2015.
There definitely is an element of risk involved, but from one standpoint, if you didn't do any simulation with the real spacecraft at all, you could argue that could pose more risk because you don't want such a critical activity only being done once on flight.
Those are all invaluable to get us ready and practiced for the one and only shot we'll have to explore the Pluto system.
We've been waiting 12 years since we wrote the proposals to do this rehearsal. It's the last big step before we can do the encounter.
We think that we are about 10 million miles out from Pluto and closing.
But so far, so good. We're off to the races. Today is our 2,724th day in flight. This has been a long time coming, literally. I only want to say thanks for all the work. Let them eat cake.
July 12th, 2013, standing in for July 14th, 2015. This is it, a minute-by-minute simulation of Encounter Day. It's make or break.
Well, it's the most important because we've best been spending the 24 hours of the most intense activities that we've been running on the spacecraft, and this is the longest that we've been out of contact since we've entered encounter rehearsal.
This may be a rehearsal, but New Horizons has been firing its thrusters and spinning in space, identical maneuvers to those planned for 2015. On Encounter Day, the spacecraft will be too busy taking data to send back images. That's why its first simple "I'm alive" message will be so important.
Sometime within the next minute, DSS 43 should lock up on the signal.
We're good. We're nominal. Spacecraft's nominal, and it looks like
all the observations that we had planned between the last track and this track happened.
So this gives us good confidence that at least the spacecraft has been performing all of those twists and turns that we've been anticipating it to over the last 7 days.
I like to say that at the flyby, I don't want to be learning anything about the ground system or the spacecraft or the team. I want to be learning only about the Pluto system.
No spacecraft has ever been to Pluto, nor will ever go back in our lifetime.
Pluto is every child's favorite planet. You know, you ask anyone under the age of 6, and they're going to say Pluto.
We don't exactly know what Pluto looks like, but it looks very exciting from the images we have from the Hubble Space Telescope so far. We really can't wait to get there and see what it actually looks like. So if anybody says that Pluto is boring or not important, no way.
Before New Horizons arrives at Pluto, most everything we think we know about the planet and its moons is up for grabs.
Virtually every place we've sent a spacecraft on a first reconnaissance mission like this, that we find out that our Earth-based notions were flat wrong. So I'll tell you what we expect, but before anything, what we expect is to be surprised.
From the 1990s through today, Stern has been consistent in avoiding speculation.
You get the same answer everybody's gotten from me for almost 20 years. I don't make predictions, except for one. My best guess is we're going to find something wonderful.
But in the final months leading up to the July 2015 encounter, it's hard for most humans not to imagine what we'll see. Many planetary scientists, like Paul Schenk, base their expectations on what we saw when Voyager 2 reached Neptune, and specifically as it flew by its moon, Triton.
Voyager was a 10-year-long exploration of the outer solar system, and every time they got to a planet, it was basically the first time anybody had really seen those bodies. So when they got to Jupiter, they were greeted with enormous surprises. The erupting volcanoes on Io were just completely unexpected. And so when they got to Uranus, there were more surprises. The exotic trains of Miranda and Ariel, for example, were not expected. So by the time they got to Neptune, they were kind of accustomed to the idea that they were going to be surprised. And sure enough, Triton completely blew them away.
Bonnie Barati was at NASA's Jet Propulsion Lab as the first images of Triton, a moon of nearly 1,700 miles diameter, came down.
Triton was almost a twin of Pluto. It's about the same size, about the same brightness.
Originally, Triton was probably a Kuiper Belt object just like Pluto, floating around in space, but then it got too close to Neptune and it got captured by Neptune's gravitational field.
Recently, Paul Schenk enhanced the original Voyager data to create this detailed flyover of Triton.
It has odd patches and odd blob-like features, kind of like amoebas crawling around on the surface. Triton has very few impact craters. Its surface is extremely young geologically.
And it actually has geysers spurting material off into space.
Here is a body that is hundreds of degrees below zero. It's so cold, it's forlorn, it's barren. We just didn't expect to see this activity on Triton. It was quite a surprise.
If you just assumed that Pluto was going to look exactly like Triton, which is the most similar object we know about, then you might expect to find a very interesting body.
But Triton is not the only dynamic ice world in the outer solar system. 16 years later, the Cassini spacecraft sent back images of Saturn's moon, Enceladus, about 300 miles across.
This is a tiny little moon, and Enceladus is actually a winter wonderland. It's very bright. It reflects almost all the radiation that falls on it, and it has these huge ice volcanoes spewing out from its south pole.
And Enceladus is continuously giving off puffs of water vapor, and so if you start to see puffs of water vapor coming off Pluto as New Horizons gets closer, that would be exceedingly interesting.
But what forces can power volcanoes in the deep freeze of the outer solar system?
Triton and Pluto are both balls of ice with presumably rock in the center, and so one of the sources of energy is radioactive decay inside the rock, which gives off heat, just like the Earth is heated. If you just let Pluto sit there and pump the heat out of the rocks, you generate enough energy to melt a couple of 100 kilometers worth of ice. It's still possible to have an ocean beneath a relatively thick ice shell. The ice shell might be 100 miles thick or so. Over billions of years, the ice shell gets thicker and thicker and thicker as Pluto cools, and as it does so, it squeezes the water underneath, and if you squeeze the water too much, then it may well actually create fractures and the water could jet out to the surface.
When you're going out to the edge of the solar system, you kind of have to expect some surprises, and we're going to see them at Pluto as well.
Just as Triton and Enceladus were mere dots before spacecraft reached them, until now, Pluto has been an astronomer's planet. That's about to change.
We are going to start off as astronomers, and we'll be using astronomical tools to try and sharpen up our images and pull every last little bit of detail out of these fuzzy blobs. We gradually turn from astronomers into geologists as we get closer and it becomes a real world.
Jeff Moore was in the room at JPL as those Triton images came down, but he also enjoys field work and thinks we'll recognize some similar planetary processes at work on Pluto as back on Earth.
So I'm a geologist, and although we don't expect to see oceans on Pluto, there are common processes which operate on this planet, which are likely to operate also on Pluto and its moons.
While the scales are very different, erosion shapes landforms here on Earth and all across the solar system.
There are these little finger-like projections that are formed by the process of erosion, where wind and water have sculpted this landscape by taking advantage of small differences in the strength of the original rock, creating large, huge, fantastic landscapes, such as on Jupiter's moon Callisto, and we can anticipate that we may perhaps also see landscapes like this on Pluto and its moons.
Pluto's 248-year orbit is more eccentric than our solar system's terrestrial and gas giant planets, greatly varying its distance to the Sun. But it's typical of many other objects in the Kuiper Belt and newly discovered planets around other stars. That, plus its highly angled polar tilt, combine to produce strong seasonal effects.
In fact, the seasons of Pluto are amongst the most extreme of any seasons on any world that we know of orbiting the Sun.
And those extremes may be one reason why its surface is also extremely contrasty.
Pluto is perhaps the most intensely bright and dark place that we've seen in the solar system. This dark surface collects more heat. It warms up like asphalt does on a sunny day here on the Earth. And if there were frost that had settled on this dark surface, they're being heated up and driven off, and the transportation of this material could also be creating wind, so you might see small dunes oriented along the periphery of the dark surface, showing this process in action.
For planetary scientists, color can be a clue to the composition of surfaces that can't be sampled directly.
On the Earth, these kinds of colors from red to dark gray are generated entirely by the presence or absence of rust. On Pluto, we see also these same ranges of colors from gray to bright white to yellow to red to black, but there it must be due to a completely different process.
At NASA's Ames Research Center near San Francisco, longtime Pluto researcher Dale Cruikshank and postdoc Chris Matarese conduct experiments to see what processes might create the colors we see on Pluto, starting with gases like methane and nitrogen and the extreme low temperatures we know are found there.
In our cold chamber, we can produce a thin film of ice and then after that expose them to a beam of electrons, which are charged particles, comparable to what comes into Pluto's surface from space. We find that when we shine ultraviolet light or electrons on simple molecules, before too long the simple molecules are broken apart, and by natural processes they reassemble into more complex chemicals. So far, the colors we make in the lab from irradiating these ices is fairly close to what we see on Pluto. There are tones of yellow, light brown, up through fairly dark red. And if we carry the processing by ultraviolet light to an extreme degree, the material actually turns black. And this is almost the color of pure carbon.
Seeing how radiation transforms simple ices into complex and colorful organic molecules should help interpret the close-up views of Pluto's surface that'll be sent back by New Horizons.
Color translates to the duration of the exposure of these otherwise colorless ices over a year, 10,000 years, 10 million years. That may in turn tell us more about the nature of the exposure of Pluto's surface and even the age of Pluto's surface.
Dale Cruikshank began observing Pluto back in 1976. Now, 39 years later, he's ready for its close-up.
We can say that Pluto is chemically active, chemically dynamic. We don't know yet if it's geologically active and dynamic, but that's what New Horizons is going to tell us. We've been surprised in that way before as we've passed other planetary bodies that we had thought were totally cold, dead, inert worlds, and find that there are geysers, there are ice flows, there are cracks, and all kinds of evidence for geological activity.
I can still remember the first time I saw Pluto in a telescope, and it was just a little dot that you could barely see. It will be amazing that within a period of hours, it will be transformed from this tiny dot that I studied as an astronomer to this huge geologic world that will be able to see volcanoes and faults and ices and mountains and craters. I mean, it'll be truly an amazing experience to see it transformed.
So, from sophisticated lab experiments, from exploring other worlds, and from applying insights from terrestrial processes, what should we expect when we get to Pluto in July 2015?
But the only thing that would surprise me would be if we turned out not to be surprised.
But enjoying the scientific surprises to come means avoiding dangers on the last few million miles to Pluto. That's next. December 6, 2014. In Mission Control, Alice Bowman and her team wait to get confirmation that New Horizons has exited what's called hibernation. For 2/3 of its 3 billion-mile journey, most spacecraft systems have been turned off, saving wear and tear on the science instruments. New Horizons sends a simple signal once a week just to say, I'm still A-OK. Alice's team has a unique way of showing spacecraft status. When New Horizons is hibernating, their bear mascot is safely asleep. When the spacecraft wakes up, they put on its party hat. If all goes well, this will be the 18th time spacecraft and bear have woken up. But December 2014 is different. VIPs from NASA are on hand. 2 film crews document the action as Alan explains the benefits of hibernation.
It lowers our cost because we don't need to have people babysitting the spacecraft 24/7.
Outside interest in New Horizons is building. If all goes well, New Horizons will stay awake, flying by Pluto in July 2015, and then returning data until October 2016.
Copy that. Thank you, GNCs.
Tonight, data trickles in, and Alice has to wait to be certain New Horizons is fully awake.
We should be getting it momentarily.
It should be any minute now.
It's like watching paint dry. I figure if I stare at the screen hard enough.
And packet 5 just came in. There we go.
PI, PM, Mom on Pluto 1. We have a nominal wake-up of the New Horizons spacecraft on its way to Pluto. We're ready for our next leg of the journey.
Was awake.
Our bear. He's going to be here for a while.
This is a watershed day. We have completed the cruise across 3 billion miles of space. The spacecraft is now awake.
Finally, after 9 years, I'm glad to see hibernation behind us and active ops ahead. On to Pluto.
But there are still hundreds of tasks to ensure a safe flyby in July 2015. January 27th, New Horizons has been sending back technical data and all seems fine. But today is the first time Hal Weaver and Andy Cheng will be seeing new science images.
I thought I saw it pop up here. Yeah, let's try that again.
Cheng is lead scientist for the LORRI camera.
LORRI is used for navigation to find the targets and to correct the trajectory so we get to the right place at the right time.
Voltages, currents, temperatures all look normal. No error messages.
This is it. Let's check out the very first images. And then Sharon, right there, peak pixel 55. That's right. Okay. All right, so there they are. Let's look at the whole
For
field.
project scientist Hal Weaver, even the jump in size from 1 to 2 pixels was significant.
This is a real milestone in the New Horizons mission, the very first images of Pluto in the Pluto Encounter year. Hadn't turned Lori on, hadn't gotten any images since last summer, last July, but this is it. This is the start of it.
How she blows.
We really don't know what we're going to see. That's what this mission is all about. What is the surface of Pluto really like? How big is it? What are the orbits really? So it's nothing but delightful surprises coming for us.
But some of the surprises may not be quite so welcome. As New Horizons gets still closer to the Pluto system, Lori will be able to identify small moons and possible rings that can't be seen from Earth. John Spencer is leading the UHAZ campaign. UHAZ stands for Unknown Hazards.
We may find new moons or even rings around Pluto, and if we see anything like that, we're going to want to determine whether it poses a threat to the spacecraft, because if it does, if there's debris that we might run into that might damage or kill the spacecraft, then we want to evaluate that hazard and determine whether we should take any evasive action.
To find out just how vulnerable New Horizons might be to even tiny dust particles, the mission sent samples of spacecraft components to the White Sands test range. Technicians at White Sands set up gun tests to assess how vulnerable New Horizons' outer covers and cables might be.
We went to 2 facilities that could shoot things into parts, models of the spacecraft.
While the results might look dangerous, the mission has options to take evasive action.
One of the backup strategies we have if we feel we need to give the spacecraft extra protection is that we orient it so that the high-gain antenna here, which is literally pretty bulletproof and can protect the spacecraft, is going to be facing forward in the RAM direction. This is RAM in the sense of battering RAM. It's a direction in which stuff will be coming at us and ramming into the spacecraft. And if that is facing forward, then any dust particles that hit the spacecraft are most likely to hit that antenna where they won't cause us problems, and only a small part of the spacecraft around the edges is going to be exposed to those particles.
That would protect the guts of the spacecraft, but limit the pointing of the cameras.
The cameras are fixed to the spacecraft, so if the spacecraft has to point in one direction, the cameras can only point in a limited range of directions. This limits the amount of times we can photograph the system as we go past, because we can only photograph objects when they're just in the right angle that we can look at them while protecting the spacecraft with the main antenna.
Another option is to take different trajectories through the Pluto system. That's called the Shabbat play.
Shabbat is the best acronym in the space business. It stands for Safe Haven by Other Trajectory. And it is the word we use to represent our backup plans at Pluto. The second Shabbat takes us much closer to Pluto, into the region where atmospheric drag depletes orbits of any debris, which we think would be the safest Hail Mary pass that we could fly if we have to do something different than the nominal. We are coming into the Pluto system with the ability, if we learn something we don't expect, to be able to make a change and get the goods.
But those decisions can only be made in the last month before closest approach, and there'll be limited time to evaluate the best options. So in February 2015, Spencer's UHAZ team, including ring specialist Mark Showalter and postdoc Simon Porter, are running through a readiness test. Now they're on the clock and being scored for whether they can work through the calculations fast enough to decide on a trajectory correction maneuver that might prevent loss of mission. And that makes this exercise more critical than any that have gone before.
The difference between this and previous operational readiness tests is that this is where we have to demonstrate to the project and NASA that we can do this.
But the only test that really matters comes on July 14th, 2015. That one day will pay off 26 years of dreams and 9 years in flight. For the science team, the year of Pluto began with another meeting to review the latest data on the Pluto system and to hear updates on how the spacecraft was performing. Mission manager Glenn Fountain, who'd been with the project from its start, summarized remaining risks. Red boxes are possibilities that could kill the mission. But now, in 2015, there are more and more green boxes, risks that have been minimized.
Something that we haven't thought of still might happen, but I'm confident that whatever happens, whatever fate throws at us, this team will be able to resolve it, and we'll go on to get wonderful data when we get to Pluto.
We have a fantastically talented team of people who have worked very hard, and we've tested the sequences inside and out. And while there are always unknown unknowns, I'm very confident and really looking forward to the curtain rising.
Along with mind-bending technical details, there also was a sense of history in the making. To document the long years of effort to get this close to Pluto, the mission recreated a team photograph taken in 2004. As Glenn, Alan, and Alice had carefully planned back then, many of the scientists and engineers were still actively engaged in New Horizons and looking forward to July 2015.
We have worked hard to get a coherent team, because if you don't have a good team to operate the spacecraft, to do the planning, you will fail. And so we worked a plan early in the mission to have younger people with the right amount of experience to be on the mission. And it's just like watching your kids grow. It's like all of a sudden, where did the time go? You know, they are older, they're more mature, and they're now the very experienced veterans.
But the hard work of mission planning was by no means over, even this close to Encounter Day. While exploring Pluto in 2015 is exciting in itself, New Horizons was recommended in part as a mission that might continue on, farther out into the Kuiper Belt. That takes identifying potential targets now for a still more distant flyby, should NASA approve an extended mission. This challenging task was assigned to John Spencer, Mark Buoy, and a team of young postdocs. And like everything else about this mission, it wasn't easy. Buoy and John Spencer had been using Earth's largest telescopes in Hawaii and Chile, but even Earth's best couldn't crack this task.
But the basic problem is the Earth's atmosphere is just a mess at these scales. There's a limit, and that's what we've been beating our heads against. Now with time running out, we had to turn to Hubble. And so we sort of, not so jokingly, talk about Hubble to the rescue. Without Hubble, we would not have these objects.
Mark and his young collaborators came up with innovative search techniques using custom software.
What that does is makes the stars smear out and makes the Kuiper Belt objects hold still.
It's been a lot of work, but to do something as exciting as this has been just so much fun. I've been plugging through the data today because it's fresh data, and I just really, really wanted to know what the answer was.
Well, we would have been in big trouble if we didn't find the KBO in time. So there was this pressure, but honestly, we had the best people in the world working on the problem, and we did it.
And we just do the math, write the software, crunch the pixels, and then I create this graphic, and from that point on, it's what I call wetware. It's what you got in your head.
In reality, KBOs are moving against the fixed stars. Mark came up with a way of making them more obvious by flipping that around and making the stars appear to move, and any KBOs stand still.
Right in the middle, there's something that's just holding dead constant. And that's the Kuiper Belt object. You can't argue with that.
It was a high-tech variant of the approach that had been instrumental in exploring the Pluto system right from the start.
But at the core, it's a technique that hasn't really changed since Tombaugh's day. You have two pictures of the sky taken at different times, and you're looking for the stuff that moves. As soon as you see something real, there is absolutely no question about it. As soon as it flashes on the screen in just a millisecond, there it is, it's real, and you know, I've found another Kuiper Belt object.
But finding a KBO is only half the battle. Is it located where New Horizons can reach it with available fuel?
Once you have the orbit, and we know where the spacecraft is and where it's going to be, we can figure out how much fuel the spacecraft is going to need to use to get to these objects.
With more Hubble time, New Horizons got a pleasant surprise.
It looked like we might actually have to burn the engines to miss the object, which was a pretty exciting concept. You know, it's a good thing we looked, because you wouldn't want to run into one of these things.
These cold classicals, they're pretty much as they were 4.5 billion years ago. They're little fossils. That's incredible. We have no idea what they're going to look like.
So with potential targets found at last, it was on to Pluto.
I'm feeling pretty exhilarated at this point. You know, you're at the top of the roller coaster, you're about to go down that dizzying, thrilling ride into the system. Just seeing Pluto there getting bigger and bigger, it gives me goosebumps.
Today, we're only a few months away from the encounter. We're less than an astronomical unit, the distance between the Earth and the Sun, that distance away from this fascinating object. It's the last major body in our solar system that we really need to visit.
To be putting the capstone on the initial reconnaissance of the solar system, it's heartwarming, and it feels like something that makes a career worthwhile.
As spacecraft goes, New Horizons is a very small team, but still, we've been working on this for over a decade, and you add it all up, and it's about 2.5 million work hours to get ourselves to Pluto.
We have waited first the 4 years that we couldn't hardly think about because we were running so fast, and then it is, oh, we wait and we wait, and now we are ready to begin the encounter. We have had delayed gratification.
The year of Pluto is, simultaneously a beginning and an ending. It's an ending in that we are completing our objective. We're accomplishing the flyby of the Pluto system for the first time. But it's also the beginning of a whole new chapter for science, of really being able to explore these objects as the data comes down over a period of months. In bringing in postdocs and the younger scientists who, some of whom were in high school when we started this project, and now they have their PhDs and they are spectacular experts and very talented at what they do.
I was in preschool when Alan first started talking about a Pluto mission, and finishing high school and starting college when it was built, and in grad school for the cruise.
Having young people come into these programs, gaining the experience, they're going to be the next generation of explorers.
We've never been to a KBO. We've never been anywhere close to a KBO. This is the most unexplored area of the entire solar system, which is another way of saying this is the most unknown area that we as humans can reach with spacecraft.
We can't wait to get to Pluto and to July 14th and see what the surface looks like. We're ready to go, and it's showtime.
We are capable of continuing an adventure that humanity began 100,000 years ago as our ancestors walked out of Africa. And we are continuing that exploration, and this country is in the forefront of doing that.